What I'm going to do for my announcements is first to share my screen. Here we go. Okay. So announcement number 1. If you look on the class Moodle page, I'm going to take you to 2 things. Factoring practice. If you have not done this, do it. It will help you. Here are factoring practice solutions. That's also there to help you. 2, I posted the solutions for test number 2. So if you want to take your test, look at the how you did, look at the solutions. I think that would be very helpful for people, and I encourage you to do that. Everyone down with me with the Moodle page? Okay. Now, also, I sent you an email last week with a link to this box folder. And I asked you all to watch and refer to these. Okay. It's 1.5 sections, really. So my hope is that you watched the video for 3.1 and got the class notes. I'm making the assumption walking in here today that you did do that. Okay. And also for section 3.2, I'm making the assumption that you watched the video and you got the notes. If I am making a wrong assumption, okay, how about this? Of you who are here, and Kiki, you can do thumbs up, thumbs down. Did you watch the 3.1 video and do that? If you didn't, it's fine. Like, I make no judgment. It's totally cool. Like, seriously. Okay, how about the 3.2 video? Okay, so I see where we're at. I love your expression, Kiki. Okay, I see where we're at. This is helpful. My friends, you got to do it. Okay? Please, please, please. It's totally there for you. I lay everything out in all its gory detail. So, yeah, this is our only class period this whole week, right? Because you don't have school Wednesday and you don't have school on Friday. And then we just have 2 weeks, and that's that. So what I want to say to you is, if you did not access 3.1 and 3.2, there's something that you have to do over Thanksgiving in addition to relax and eat and sleep and the rest of the things. Okay, please. You dig? Cool. Now, I am going to jump over to our MyOpenMath page. In the MyOpenMath, what I'm going to do in front of everyone's face is formally assign this homework for 3.1. And I'm not going to do that for 3.2 yet, because we're probably not, well, now, given where we're at, we're definitely not going to finish it before Thanksgiving. Okay. But 3.1 is due a week from today. And what I want to do is I want to talk to you for a second about section 3.1. Okay. 3.2, that video that I made that's on the box folder, I showed you. I went through part of the section. I was hoping to finish it today, but you know, life isn't what we hope for. Welcome, right? So I'm totally cool with that. What I want to say about this 3.1 online homework is that the first 10 questions are all section 3.1. You're like, okay, that's cool, Lauren. There's 4 more questions that are tacked on at the end. Those 4 questions, and what you're going to see is each homework assignment you have in chapters 3. So you're going to have 3.1, 3.2, 3.3, 3.7, and 3.8, I think. You're going to have questions from the previous material. Okay. Again, the reason why is because just because we're moving on to new things doesn't mean that you should forget what we've already done. So what you're going to see is the last 4 questions in section 3.1 are, in this particular instance, linear equations. Just so that you keep up the practice, because as we know, once you stop practicing things in math, it sure goes out of your head really quickly. Okay, so this is just to kind of keep you in gear. Again, we have one more test. Okay, let me do this. No, I'm going to get out of this for a second since I started it. You have one more test. You have a test 3 on chapter 3. Plus, I'm going to throw in, you know, a couple linear and exponential things in this last test. It's on your syllabus. We'll talk about this stuff next week on Monday when we're back from Thanksgiving weekend. But this test is on your syllabus. It falls during finals week. Finals has things in 2-hour blocks. I'm writing this to be a regular hour exam. Okay. So the reason why I say plus is because there's going to be some chapter 2 and chapter 4 ideas in here. That's why I'm throwing in online homework so that you kind of keep hip to the practice with that. In addition, and this is totally optional, if you're content with your test number 1 score, your test number 2 score, and you feel confident on test number 3, cool. Take test 3 and say, see ya, and have a lovely winter break. If you did not do as well as you hoped to do on test 1 or on test 2, or if you feel like test 3, you took a nosedive, I am going to give an optional test that you can take during this time period right after test 3. And it's going to be a 1-hour all semester material stuff. Okay. What I will do with this optional test is it can replace 1 low test score. Okay, I will only replace 1 test score with it. I will replace your lowest test score with it. If you do worse on this, so suppose you're like, oh, I'll give it a try, I'm already here in the math mode. If you do worse on this than you did on test 1, test 2, or test 3, we'll just pretend that this did not happen. Okay, so it can't count against you. But I want to recognize the human aspect of life in that we all have bad days. And I want to give you an opportunity. So suppose you did decent on test 1 and you bombed test 2. I want to give you an opportunity to show me that you can do that material, right? Because in the end, that's what I care about, not by one artificial due date I have to set as opposed to another. Okay. So we'll talk about this at the end, but I just want to let everybody know that you do have a mulligan. Okay. Any questions on this? All right. So what I want to do now is I want to address a particular question that someone in here had on the online homework in section 3.1. Okay, and this is question number 9. Your question number 9 might look different than my question number 9, but it's really all about the vibe, and I'll talk through it. Okay. First thing I need to say, when you're doing these problems and writing things in interval notation, the way you write infinity is lowercase o's. If you use zeros, they're going to mark you wrong. It's just the way online programs work. Okay. So what I want to do is go through this. Now, some of this question 9 is specific to this particular section. Some of it actually dates back to chapter 1, when we talked about increasing and decreasing functions. So first thing is they ask, what is the domain of this function? The domain are your x values. Well, one of the things we learned in section 3.1 is that the domain of any polynomial is all reals. Okay, it's always going to be all real numbers for any polynomial function we look at, precisely because there's no log, it's polynomial, and we don't have to worry about dividing by 0, and we don't have to worry about taking square roots of negative numbers. Okay. So for this portion of it, they first want to know what it should look like. Well, I know my domain is all real. So notice I have parentheses here. And then I say it goes from negative infinity to positive infinity. Okay. You with me there? Cool. Now, we want to know the range of this function. With some polynomials, our range is also all real numbers. Okay? With quadratics, it's not always going to be. In fact, it won't. So when we're talking about the range, we're talking about our y values or our function values. Okay? So would you grant me that my y values go all the way down to negative infinity, right? They say assume there's arrows at the end of the graph. Isn't as big as we get function value wise right here? And isn't that at 1? So I claim it goes from negative infinity to 1. Now I actually do take on the value of 1. So I need to have it in this form where it's a parenthesis and a bracket. It's a parenthesis next to the negative infinity, and it's a bracket next to 1 because we actually do take on the value of 1. You with me this far? All right. Next part, increasing. Remember, increasing means as we move from left to right, where is our function value? Where are our function values going up? Would you grant me that this is increasing to here? Now, this rings back to a detail that we had back in chapter 1. You can tell where a function is increasing or decreasing by your y values, right? Whether they're going up or going down. But the way you express it is by using your x values. And the other key thing to note is you have to use parentheses, because technically it means nothing to be increasing or decreasing at a point. You're increasing in this interval. So I would say that where my function is increasing is here. So it starts at negative infinity, and I'm increasing all the way to here. What x value is that? -3. And this is one where both are parentheses. Okay, again, whenever you talk about increasing or decreasing, you always have parentheses at both endpoints. You with me there? Awesome. Okay, so the last question, or the last part of question number 9, is where, on what interval is this function greater than or equal to 0? Okay, well, greater than or equal to 0 for our function values. Doesn't that translate to where are our y values? 0 or higher? Okay, well, I claim my y values are positive, or, well, they're 0 when I'm on my x-axis. They're positive when I'm above. So I would claim that this function is equal to 0 at -4 and at -2. And in between, it's greater than 0. So the way I would write that one is with 2 brackets, and it's positive from -4 to -2. Notice I have brackets there because I'm counting those 2 values of -4 and -2, because that's where my function is equal to 0. So if I asked you, where is this function less than or equal to 0? Wouldn't that be here and then here?
Yeah.
Any questions on this? Ross, does this help?
Oh, yeah. I was just confused with what the A was and the B was.
Those are just your endpoints. Yeah, it's kind of a funky written question.
So it helped a lot.
Yeah. Yeah, knowing what's going on can be rather helpful. Any other questions in this 3.1? So if you have not gone through 3.1 yet, please do it this weekend, okay? If you have not gone through the first part of 3.2 yet from those, and again, I'll take you, it's in the box folder. Do that. Now, if you're wondering how you knew you were supposed to do this, I sent the class an email out last week and I had it linked. I had each thing linked very specifically. So if you just go through your emails from me and you go to the most recent one sent to the class, you will see that there's a link to the notes. There's a direct link to each of the videos. So I do urge you to please catch up on those. You cool there? Okay. All right, so I have to ask because I care. Is everyone have decent plans for their Thanksgiving or long weekend? Are you glad not to have any plans? You are? Are you okay? Okay. Okay. Yeah. Here? Cool. Do you have someone to take care of you? Okay. Cool. Anyone else doing anything better than sinus surgery? Cool. How about you? Nice.
I think I'll actually touch my Xbox. I haven't touched in like 3 months.
Oh, congratulations. I know how my son would feel about that. Yeah, I hopefully gonna go ski, and every year it's a toss-up. Do we do bean burritos or enchiladas? And this year it's an enchilada year. So I'll eat enchiladas. I know it's not Thanksgiving food, but I don't eat turkey. So
Understand.
I know,
I mean, duck.
I don't, you're right. I'll eat some apple pie. Okay. That's what you'll. Okay. Well, I mean, and plus it's a funky year anyway. My son's in Japan. Who knows what he's going to be doing? Kiki and Finn, do you have good plans for your weekend? Cool. You're not going to Chicago, are you, Kiki? Dinner with the fam. Good for you, Finn. Kiki, are you going? Oh, absolutely not. No wonder why you're having good plans. Me either. Cool. All right. So we have a little bit of time. And I wanted to take where I left off in my notes in 3.2 and start from there. But I won't. So I suppose what I'm going to do is I'm going to do a big overview of what you're going to watch in detail. Okay, so for those of you who've watched it, this is going to kind of tie things together. For those of you who have not yet watched it, this is going to be an idea of what you're going to hear. Okay. And again, I'm taking the very generalized approach here. Okay. Because then what we're going to do when we come back, so a week from today, I'm going to wrap up 3.2. So please be ready for that. Okay. Puts us a day behind, but that's okay. We'll fix it. Cool. Okay. So just in general, in 3.1, we talked about polynomials in general. In 3.2, we're focusing on quadratics specifically. Okay. Quadratics are second degree polynomials. So they're of the form ax squared plus bx plus c. A, b, and c are real numbers. And a can't be 0. B and c could be 0, a can't be, precisely because if a is 0, doesn't that nix my first term? And then we actually have a linear, we don't have a quadratic anymore. Okay. So one of the things that I talked about is the basic shape of these graphs. Okay, these graphs take the form of a parabola. Okay, your parabolas can open up or they can open down. Some important properties of parabolas is as follows. This point right here is special. It's called your vertex. Okay, the nice thing about your vertex is if you draw a vertical line through your vertex, it's called your axis of symmetry. One side is a mirror image of the other side. When your parabola opens up, your vertex is your minimum function value. That's important, especially when we get to applications. When your parabola opens down, this point is your vertex. This is still your axis of symmetry. But notice when your parabola opens down, your vertex is your maximum value. Again, that's really useful. We talk about parabolas that open down a lot because when we talk about shooting projectiles, for example, they go in a parabolic shape. Okay, and when we want to know what the maximum height projectile might be, we're going to find our vertex. Okay, it's really nifty. Now, a couple other things that tie back to section 3.1. The parabola opens up if your leading coefficient is positive. Your parabola opens down if your leading coefficient is negative. All right. In this section, we also saw that there's different ways of writing parabolas. This is called your general form. The beautiful thing about being in the general form is you can easily find your y-intercept. How do you find your y-intercept? Isn't that your value of y when x is 0? And the nice thing is if you plug in x equals 0, you cover up the terms with x in it and you can read off your y-intercept. Another thing that I went through, sorry about all these lines. I got to get a new cord. Another thing that we went through in this video that you are going to watch is a shortcut way of finding your vertex when you're in this general form. The shortcut way we saw is the x value is negative b over 2a. I love shortcuts. And once you have your x value, you can then plug it in to find your corresponding y value. Okay, so that was a bit of my spiel there. Okay. The next thing that I mentioned is that we not only want to be in general form, but there's also value to being in what we call vertex form. And vertex form is when it's written something like this. Your vertex then is the ordered pair HK. In my video, and I'm not going to go through this in here, what I do is I take you through in detail the steps from going from this general form to this vertex form. You use a technique called completing the square. Okay, I go through that in all its gory detail. The nice thing about being in this form, I mean, let's just suppose we have 2x plus 3 squared minus 4. I can read off my vertex straight up here. Okay, I claim, notice you have x minus h and then h. It takes the opposite sign of what you see in here. So my vertex here would be -3, -4. Now, the cool thing about having it in this form is you can jump back to section 1.5 and use transformations. You could say, well, we take a general parabola. What happens when you add 3 inside? Doesn't that shift it to the left 3? So we shift it to the left 3, and then -4 tells us down 4. And this times 2 just means make it thinner. So this tells us take your general parabola, y equals x squared, move it left 3, down 4, and this is the general idea. Notice that totally jives with my vertex of -3, -4. Okay, so that was the next thing that I talked about in that video. Okay, it's important to be able to take it from general form into vertex form. And I go through several examples of that. Okay. The third form that we have for our quadratics is factored form. Not every quadratic can be factored, but when you're in factored form, the coolest thing of it is you can read off. We have a lot of the same names you can call it an x-intercept, your horizontal intercept. They're called your zeros or your roots. Okay, this is the quick and easy way to find what your x-intercepts are. Okay, precisely because when you're in factored form, to find your x-intercepts, by definition, don't you set your function equal to 0? Well, when you're in factored form, you can use that product of 0 property, right? The only way you can multiply two things together and get 0 is either if the first one is 0, the second one is 0, or both, right? Isn't that the only way you can multiply things together to get 0? Well, this 2 has no effect, right? 2 is not 0. So what we say is, well, then either x minus 7 is 0 or x plus 4 is 0. So here you would get one x-intercept of 7 and one x-intercept of -4. Okay. What I went through in the video was all the gory detail of our techniques of factoring. So if you don't remember how to factor, that is another beautiful thing about the video. If you get to that point in the video and you're like, I am totally down with factoring, then you can totally fast forward through the video. That's the beautiful thing about videos. Okay. So the ending part of my video was to take things that are not yet factored and put them in factored form. Okay, so let's just take an example here. Okay. Hold on, I need to do something. Okay, so for example, whoa. For example, whoa. Let's go back. Ah, come on. There we almost go. Okay. So if I want to, for example, find my x and y intercepts of this guy. Okay. To find my y-intercept, how do we do that? We set x equal to 0. Tell me, what is my y-intercept? -28, right? If you plug in x equals 0, that just nixes our first two terms. See ya later. Okay. To find my x-intercepts, what I'm going to try to do is factor this. Okay, so our goal is to factor, set it equal to 0 and factor. I'm going to do two examples. This is one example where the coefficient in front of your x squared is 1. Again, I showed you on your Moodle page that factoring practice. If you do all of that, you're practiced and then some, okay? But remember, what you want to do is find two numbers whose product is the last number and whose sum is the middle number. What I tend to do, and I go through this in detail, is I say, well, what multiplies to 28? 1 and 28, 2 and 14, and 4 and 7. Which pair is going to work? 4 and 7, totally. In fact, it's going to be x minus 7, x plus 4. I knew one was positive and one was negative because that's the only way you can multiply up to a negative number. And I knew that the larger one was negative because my sum was negative. So what's one of my x-intercepts? 7, and what's the other one? -4. Okay. What if I want you to find your X and Y intercepts of this guy? Well, our y-intercept is what? 0, -6. Okay, again, when you're in this general form, you plug in x equals 0. It's totally sweet. These things just go. Okay. To find our x-intercepts, though, what we have to, oops, I don't need to put it in parentheses. What we have to do is factor. Well, notice when you don't have a coefficient of 1 in front of your first term, you can use trial and error. In other words, just play with it. But I also gave a procedure that will always work if it is factorable. Okay. You want to find two numbers whose product is your first number times your last number, and whose sum is your middle number. Well, which pair of numbers is going to work? Totally 3 and 4. And wouldn't you grant me that -3 and +4 are the working ones? -3 times +4 is -12. -3 plus 4 is 1. Recall your next step is to rewrite your middle term using those numbers. Again, watch the video. I claim what I wrote here is no different than here. I just made it look longer. Anyone remember what the next step is? Factor by grouping. What can you pull out of the first two terms? Just one x, right? And if you pull an x out of the first term, we have a 2x left and then a -3. What can I pull out of my second group so that I'm also left with the 2x -3? I can pull a 2 out, right? 4 and 6 have a 2 in common. And then aren't I left with 2x -3? Now I have two terms and they have something in common. So I can pull that 2x -3 out. If I yank this 2x -3 out of my first term, aren't I left with an x? And if I yank it out of my second term, what am I left with? +2. So I claim if we set this first one equal to 0, we're going to get x to be 3 halves. And this second one, we're going to get x to be -2. So this is what we played with. The one other thing that I'm going to do, just because this is where I'm going to pick up next time, is talk about completing the square. What I want us to do right now is just take a quadratic and put it from general form to vertex form. This is to remind you how to complete the square, because this is what we're going to pick up on first thing a week from today. Sound okay? All right, let me just do something. I'm making it up. That's why it's taking me a second. Okay. So for this example, suppose I have y equals 2x squared minus 12x plus 21. Now we can totally read off our y-intercept here, right? What is my y-intercept? 21. Y'all cool there? Awesome. Okay, So all I'm asking us to do for this one is for us to find our vertex. Now, I love my little shortcut cheating method. I honestly pretty much do that. But let's practice completing the square just because it's going to be helpful in the next, what I'm going to motivate next. Now, I will say that in general, because a lot of things can't be factored, we are going to need other techniques to find our x-intercept. And that's what we're going to be working on next week. Okay. You may or may not recall, but the first step is to make sure you have a 1 in front of your leading term. If you don't have a 1, what you need to do is you need to factor it out of your first 2 terms only. So if I pull this 2 out, do you agree? I now have it written this way. I have not changed the value. You can distribute here. Okay. My next step, and again, we go through this in detail in the video, is take half of this number. What is half of -6? -3. I tell you to write it to the side. Okay. You'll see why momentarily. Once you take half of that middle term, what you do is you square that number. What do you get when you square -3? 9. Add that inside. Now, I've just added a number onto this equation, haven't I? I need to keep it the same. I mean, at this point now, I don't have 2x squared minus 12x plus 21. I've got 2x squared minus 12x plus 39. Right? Because if I distributed my 2, haven't I essentially added on 2 times 9 or 18? How do you balance adding on 18? Subtract it. And again, I go through this in total detail. Do you agree that 21 minus 18 is 3? Now, what you want to do then is write the thing in parentheses as some quantity squared. The question is, what number goes here? You remember when I told you to take half of this term and write it to the side? That's the number that goes there. So what's my vertex here? 3, 3. Now, could we have done that with x equals -b over 2a? Yeah. But I want you to play with this technique. Okay. Now, last but not least, I have 3 minutes left. I'm just going to say one more thing. We have the x-intercept issue. You know, you can have parabolas that look like this. And do you agree we're going to have 2 x-intercepts? You can have parabolas that look like this. And don't you agree we have 1 x-intercept? But I can also have parabolas like way the heck up here that open up, or way the heck down here that open down. Are these going to have any x-intercepts? No, this is never going to touch or cross my x-axis, right? Because this is my minimum value and then it goes up to infinity. This is my maximum value and then it only gets smaller from there. Okay. So when we can factor to find our intercepts, that is when life is pretty ideal. The thing is, you can have x-intercepts that, but you can't get them from factoring. Not everything is factorable. Okay, so for example, here, let me just do, just give me 1 second. Okay, so for example, I can take, well, let's just take this guy. Suppose I asked you to find your x-intercepts. And let me put in, or whatever, +1. Suppose you wanted to try to factor this. Is it factorable? I claim not, right? Because you would need two numbers that multiply to a positive one that add to a positive one. Well, what are the only numbers that multiply to 1? 1 and 1. But is there any way with the pluses and the minuses that this can add to a 1? No. So then the question is, how do you solve something like this to find the values of x that make this 0 if you can't factor it? And that's what we're going to get into next week. And that's what's going to take us to our quadratic equation. Was that an okay overview to just tie things together? Awesome. So I hope you all have a great Thanksgiving.